We're going to look at consumer behavior. In this unit, we will discuss how you and me consume goods X and Y with limited budgets. We'll look at the concept of indifference curves and the rate of marginal substitution. We'll also look at how to compute budget constraints and constraint optimization using Lagrange. We'll also look at consumer equilibrium using utility maximization. So to start with, the behavior of human beings is rational in the sense that humans want to consume more for less. Had there not been any scarcity, we could have a situation where humans want to consume endlessly. But because there's budget constraints, we are often limited to the extent to which we can consume. And this is what we call constrained optimization. The budget line often looks like this. The downward sloping curve for good Y and good X. So under constrained optimization in utility, we're going to look at what is called satisfaction. Satisfaction is measured in units called what? U-towers. The U-towers measure utility. Now, utility is a measure of satisfaction by what we call indifference curves. So, indifference curves are very important curves in economics, which have a number of properties. So these indifference curves look something like this. Okay, so what are some of the properties that indifference curves have? So indifference curves, as you can see, are parallel to each other. They don't crisscross. They are downsloping. What else can you see? About indifference curves? What else can you see about indifference curves from there? They are downward sloping, they are non-intersecting, they are uniform, meaning they offer what we call marginal rate of substitution. They are transitive. So you'll be asked sometimes using the graphical representation to give an overview of what indifference curves offer and the principles behind there. So let me just go through them again. So indifference curves are simply graphical representations that are used in economics to illustrate consumers' preferences between two goods. So they're downward sloping. So this simply means that they slope from the left to the right. It means that as one unit of a good increases, you are going to decrease consumption for the other. So indifference curves are also non-intersecting. They are non-intersecting, they do not crisscross. If they did, it would imply that a consumer are different, is indifferent between two different levels, which means that it violates a fundamental assumption that is there, that each indifference curve is unique. So they are convex to the origin. This simply means that they are bowing inwards. The shape that comes out like that, that is a convex shape. So meaning this reflects the principle of diminishing marginal rate of substitution, which states that as a consumer gets more of one unit or one good, they're willing to give up the other. So indifference curves are also transitive. Transitivity simply implies that indifference curve represents consistent preferences. So if one bundle of A, if a consumer prefers one bundle of A to B and B to C, it means that they must prefer A to C as well as transitive. So if we have these curves, so if A, B, C, so if A is lower than B and B is lower than C and C is higher than both of them, so meaning the consumer will prefer C to both of them. So this property ensures that we have a logical consistency when we're dealing with indifference curves. All right? Are we following? Are we together? The other properties of indifference curves are as follows. We have a property of completeness. So indifference curves cover all possible combinations of goods that a consumer can choose from. In other words, for any two goods, X and Y, a consumer can rank them as either preferred, indifferent, or less preferred. Then the higher indifference curves will offer a higher utility. So like I illustrated earlier on, if we have indifference curves A, B, and C. So in this case, indifference curve 1, indifference curve 2, indifference curve 3. So A, indifference curve 3 is higher than indifference curve 2, which is higher than indifference curve what? 1. This is how it follows. So they follow this hierarchy. Indifference curve map, a set of difference curve representing different levels of utility will form an difference curve map. This helps us to visualize the consumer's preferences at various goods. So difference curves do not touch the axis, they're infinite. They cannot intersect each other, then they don't even touch the bases. So as you can see, if you're going to draw, it will not touch, it will be like this. It doesn't touch any of the axes. So this means that if they did, it would mean that the consumer is willing to consume one good in isolation without consuming the other. So it doesn't touch. Then we also have uniform marginal rate of substitution, which means that the slope of a difference curve remains constant throughout. So meaning when we are looking at satisfaction at this point and at this point, it's the same, except that if you are moving from point A to point B, you need to give up certain numbers of goods from point A to consume more of point B. So what we are trying to say is, if we have Y here and X, so if these are indifference curve, and we are talking about, and so we have 3 and 4, we have 5 and 7. We're looking at opportunity cost. So if you're foregoing 1 unit of good Y, reducing from 4 to 3, it means you're going to gain 2 units of X from 5 to 7. So foregoing 1 unit of 1 gives you what we call the marginal rate of substitution. Marginal rate of substitution X for Y is simply the price of good X over price of good Y. So if the price of good X, for instance, is maybe 2 kwacha, price of good Y is 8 kwacha. So the indifference curve of good X for Y is 8 into 2, which is a quarter, or 0.25. If you are asked to find the marginal rate of substitution Y for X, in this case, we're going to start with Y, since it's a beginning there, divided by price of good X. So here we're going to have 8 over what? 2. So which is what? -4. So this is what we call our marginal rate of substitution. Marginal rate of what? Substitution. So indifference curves are very important under consumer behavior because they help us illustrate a number of key issues. How satisfaction can be measured. So now let me take you to basic illustrations of what we call budget lines. Let me illustrate illustrations of what we call budget lines. From our first topic, we should get it to say a budget line is given by I is equal to price of good X times X plus price of good Y times Y. So I stands for the income. Price of X, PX. Price of Y, PY. So if you're given the income, for instance, as 100 kwacha, and the price of good X as 2 kwacha, the price of good Y as 8 kwacha, or say 5 kwacha, and ask you to come up with a budget line. So budget line, given the formula that I've given you, will be given by what? Income is equal to price of good X times X plus price of good Y times Y. So here our income is 100 kwacha, good X is 2 kwacha, so 2X, good Y is 5 kwacha, so 5Y. So this becomes our budget line. So how do we illustrate this budget line? So to plot a linear equation, the easiest way is to calculate the intercepts. So these two, just divide it into 100 to know where to cut the X. And this 5, just also divide it into 100 to know where to cut the Y axis. So we know the budget line will go this side. That is Y and X. So let's divide 2 into 100. What do we get? 50. About 5 into 100, what do we get? 20. So this simply implies that this equation will cut the y-axis at 20 and will cut the x-axis at 50. This is how we sketch budget lines. Now, budget lines are very important because they give you how much you're going to consume of good 1 to good x or to good 2. So in this very question, suppose I told you to say, if this particular person decided to buy 20 units of good X, how much of good Y are we going to find? So you go into this particular equation, you can illustrate. If here, this is 20, what is the value of good Y? How many units of good Y are we going to have? We simply substitute now in this equation. 100 is equal to, where there's 20, where there's X, we put 20. This is 5Y. Here, this is 100 is equal to what? 40 minus 5Y plus 5Y, sorry. So the 40 will subtract there. So we're going to have 100 minus 40 is equal to 5Y. So here I have 60 is equal to what? 5Y. So to get, we'll divide both sides by 5. So our Y will therefore be equal to 12. So this is how we calculate the value of how many units of Y will be consumed if 20 units of X are consumed. Let me illustrate another question. Suppose the price of good X is 4 kwacha. The price of good Y is 10 kwacha. And the income, sometimes it comes with letter M, is 40 kwacha. Can somebody help me? What is the budget line? What's the budget line? Those parameters. Income is what? Price of good X times X plus price of good Y times Y. Can somebody help me substitute? So what do we have here? Anyone?
So you have 40 for income.
44.
And price of X is 4. Price of Y is 10.
So we're going to have 40 is equal to what? 4x plus 10y. All right. And how do we sketch this equation? Somebody else? This is of course our y. This is our x. How do we close this equation? The intercepts. How do you get the intercepts? So x, we divide 4 into 40. What do we get? 10. And the y, 10 into 40. What do we get? 4. So here we're going to draw this line there. So for the y, it will cut at what? 4. For the x, it will cut at 10. This is our illustrated equation. Now, if they ask you that suppose this individual decided to do the following, okay? So suppose we are told that this person decided to consume 5 units of good X. 5 units of X. How many units of Y can they consume? So you now substitute. Okay. So we substitute where there is X. We're going to put 5 for this X, but you're going to have 40 is equal to 4. Where there's X, we put 5. And where there is Y, that's what we want to calculate. So we're going to compute that. What do we have? 40 is equal to 20 plus 10y. When this one goes there, to be 40 plus 20 is equal to 10y. And here we're going to have 20 is equal to 10y. We divide both sides by 10, even here by 10. So here we're going to have a 2. So what does that mean? It means that whereas we're going to consume 5 units of X, how many units of Y are we going to consume? We're going to consume 2 units of Y. So this is what really happens in this scenario. Now let me submit to you the behavior of these curves. So whenever the income increases, the implication in the curves will be such that the graphs will shift outwards, meaning you're able to consume more of that unit. This is a shift outwards. This is as a result of an increase in what? Income. If your income reduces, there'll be a shrinkage. It will shift inwards. So this is because of a reduction in your income. Income is noted by M, Y, or I. So this is increase in income, and this is decrease in income. Are we together? Then there are certain times when goods become cheaper. For instance, if good Y is becoming cheaper, it simply means that we're going to increase consumption on Y. Because we're able to afford more of good Y. So this is called a tilt. So the function will tilt outwards because there has been a reduction in the price of good Y. However, if the price of good Y becomes expensive, it will tilt inwards here. So this is because the good Y has become expensive. Similarly, if we're dealing with good X and good X became cheaper, there'll be a tilt that will move outwards. So this is because good X has become cheap. But in the event that good X becomes expensive, leaving good Y as it is, so that it being tempered, we're going to have a tilt, which is going to be symbolized by this curve. So these are the two important movements that you need to take note of. Now, how do I illustrate these movements in terms of a question that may come in an exam setting? Right? So this is consumer behavior reflecting how we behave. For instance, suppose your income is 1,000. And we are told that good X the price of good X is 100 kwacha. The price of good Y is 50 kwacha. Budget line now becomes what? Income is equal to price of X times X plus price of Y times Y. So in this case, we're going to have 1,000 is equal to 100 plus 50Y. Here is X. So to plot this, the intercepts we divide by 100 here, 100 there. Will give us 10, 50 here, 50 there. It will give us what? 20. So to draw this budget line, we're going to cut the Y-axis and the X-axis. Y on 20 and X on 10. How to get on sketching this? How to get on the sketch?
Yes.
Right. Now, we're told so suppose we're told that income doubled. From 1,000 to 2,000. What becomes our new budget line? 2,000 is equal to what? 100 X plus 50Y. So to illustrate this, we divide 100 into 2,000, get 20. 50 into 2,000, get 40. So as you can see, there's a scalar increase here. So from 20 to 40, from 10 to 20. So there is a shift in the equations. Suppose income halved, it reduced by half. So our income equation from 1,000 to go to 500. So here we're going to 500 is equal to 100 X plus 50 Y. So 100 into 500, what do we get? We get 5. 10 into 500, we get a 10. 50 into 500, we get a 10. So what happens in this case? There'll be a shift inward. It will shrink from 20 to 10, from 10 to 5. So this is because the income has reduced. So this is the consumer behavior that we want to understand. Now, suppose we maintained the same income of 1,000, the price of good X and the price of good Y we maintained as 150. So the initial equation will still be cutting the Y and the X. So 50 into 100 into 1,000 for the X, it will cut it at what? At 10. Then 50 into 1,000 to get at 20. Now suppose that we are told that the price of good X doubled itself from 100 to 200. that this one will remain the same. So 50 into 100 is still 20, so this will be maintained. But 200 into 1000, what do we get? We get a 5. So this 5 is simply symbolizing a tilt. So we're going to afford less units of good X because it has become expensive. Suppose instead of going to 100, it went to 50 as well there. So 50 into 1000, what will happen? This 200 into 1000 will get a 5. 50 into 1000, we're going to get a 20. So here it will cause a tilt outwards from 10 to 20, verifying what I was just explaining under our consumer behavior. So any questions this point? Any questions at this point? All right, so we now go to introduction of the utility functions. Now, with the introduction of utility functions, you must understand that utility can be optimized at a point where the indifference curve is a tangent with a budget line. This is a utility maximization point for good Y and good X. So we use what we call the Lagrangian multiplier to calculate the point at which good X and good Y are maximized. So this is a long formula that you will need to know, but I'll summarize it for you in the simplest possible manner. So this is called the optimum bundle, which occurs when the marginal utility of X over the price of good X equates to the marginal utility of Y over the price of Y. In the event that you're given a utility function, say 2x to the power half, y to the power half, and the income is given, for instance, as 80, and the price of good X is given as, let's say 10 kwacha, and price of good Y is given as, let's say, 40 kwacha. But one, find the budget line. Who wants to try to do the budget line? What is our budget line?
Our budget line will be 80 is equal to 10x plus 40y.
So 10x plus 40y. Can you plot it for us? Why would it cut the y-axis and the x-axis?
So
Right.
x-axis will be 4 and y will be on 2.
For x, you divide 10 into 80, which is what?
Yes.
8.
10 into 80 is 8. So yes, 8.
Y is 40 into 80, which is what? 2. Now I want to find the optimization point here, point B. All right. So initially, today earlier on, we were learning how to differentiate the utility function. Imagine our utility of x is when you differentiate du over dx. So in this case, our dummy is what? Y to the power half. So we differentiate 2x to the power half. What do we get? Half times 2 is 1. We never write 1. Half minus 1 is negative half. The marginal utility of y is derivative of du over dy. dy. So in this case, we're interested in the y. Our dummy is what? x to the power half. So we're going to multiply half times 2 is 1. We never write 1. Then when we subtract 1 from the half there, we're going to have negative half at this point. These are the partial derivatives that we are interested in. The marginal of x, the negative is on the x. Marginal of y, the negative is on the y. So the optimum bundle is when we divide the marginal of x with the price of x to be equated with the marginal of y with the price of y. So marginal of x, I said the negative on the x. The marginal of y, the negative is on the y. And the price of good x was what? That's the price that we have here. Was 10 kwacha. Price of good y was what? 40 kwacha. At this point, are we together?
Following.
Okay. So now, using indices, the guy with the negative will go down there. So in this case, which guy will go down? The x. So x to the power half. And here, which guy will go down there? Our y. So y to the power half. So cross multiplying this will give us 10x, because 10 times 1 is 10. X to the power half, and x to the power half is x. Then we'll multiply this, will give us 40y. So x is equivalent to 4y. This is how our partial equation will be. Are we together so far? Look at the jargon that I've just done there. Can you understand what's happening there?
I'm a bit lost. How did we lose the negative half on x?
So when this negative comes down there, it becomes a positive. It's a row of indices and it goes down to join the friend. Similarly, when this guy goes down there, it becomes a positive. That's a row.
Okay, I see.
Any other question? So now we know under indices, say x to the power 2 and x to the power 3, you get x to the power 5. If we have x to the power half, so the 5 is because we're adding 2 plus 3. We have x to the power half times x to the power half, so to x to the power 1, which is x. Okay?
Yes, so just if I get you clearly, when we are deriving at this point, we have to use the rules of indices for us to arrive at these numbers.
Yes. So here I'm cross multiplying 10x half times 1 half, 1x half, it is 10x. 1y half times 40y half is 40y. Then divide both sides by 10 by 10. So x is equal to 4y. Then we go back here. Since x is 4y, we substitute it in here. Okay. So in this case, we're going to have to substitute this function here. So we're going to have 80 is equal to 10 for y plus 40y. So here 80 will therefore be equal to 40y plus 40y. So this is going to be 80 is equal to 80y, meaning our y is equal to 1. So we substitute our y here to get the x. So where there is y, we put a 1. That means our x therefore will be what? 4. So it follows that our x is 4, our y is 1. So this question will give you 10 to 15 marks. This is how we go about. Are we together? So this topic really attaches with the topic of differentiation that we did. I hope we didn't miss that topic. All these topics are very interrelated. Any questions? So my homework for you will therefore be to calculate last year's question paper, which had 10 marks on this similar. It actually came from your handout. So you will try to do this question. Jacob's function is given by 10x squared y. The price of good x is 10. Price of good y is 5 kwacha. And the income is 150. We're asked to show the optimal combination. So let's quickly try together, although this will be homework. What's the budget line in this case? Income is what? Price of x plus price of y, y. So income is 150. Our price of x is what? 10. The price of y is what? 5. So put this one here. It will cut the y-axis at what? 5 into 150, which is what? 30. The x 10 into 150, which is what? 15. Are we together so far? Are we together so far?
Yes.
Yes.
Then we're given a digit function as 10x squared y. So to find the marginal utility of x using this function, u is equal to 10x squared y. What is our dummy in this case? The u over the x. What is our dummy? Our y. Then we differentiate 10x squared, which is what? 20x. Are we agreeing? Then our marginal utility of y will be the u over the what? The y. Our dummy in this case is x squared. We're going to differentiate 10y. The derivative is simply 10. These are the two functions that we need to use them. So the marginal utility of x over the price of x will be equal to the marginal utility of y over the price of y. So what is our MUX? 20xy. What is our marginal utility of y? 10x2. The price of good x was what? 10. Price of good y was what? 5. So when you divide this in there, we're going to have 2xy and here 2x squared. At this point, are we together?
Yes.
So we divide both sides by 2x, even here by 2x. So meaning we're going to have x is equal to y. We divide both sides. Then we go back to our original function here, where there's x or where there's y, you substitute the other data. So what do we have in this case? We're going to have 150 is equal to 10y. Since I've substituted where there's x, I put the y. And here I'll leave it as it is, 5y. So this will give us 150 is equal to 15y. So the value of y, according to this, is the value of x. So when divide both sides by 15, we're going to get our y to be 10. So x is 10 and y is 10. This gives you about 10 marks. So this question usually doesn't miss in most of the exams. So let's see what they did. They calculated the budget line. They use a Lagrangian function. This function is long, but it will still give you the same answer. We equate them to 0 and do the partial fractions and partial derivatives. And it take you to the value of x, which is 10. The value of y is as good as the value of x. So this is the homework I need you to do. So it's simpler in this format. You're able to do it on one page and exhaust everything. Thank you so much for your time. Have a good evening, unless any questions. This question here, utility function was Q1, Q2, the price of good. X was P1, price of good. 2 was P2. The income was 120. Does anyone want to try to give an idea of what to do? Does anyone want to give an idea of what to do?
So we'll first find the budget line, which is our income, which is equal to 120, is equal to P1, which is 1 plus P2, which is 4.
Okay. Correct. We'll first find the budget line, where in this case, our 120 is equal to 1 P1 if you want, plus 4 P2, dealing with the functions, correct? And this is x or y, depending whatever you want. Then the utility function is here. Okay. So utility, imagine utility of what? A good one. Meaning our dummy is Q2. So 1 Q1 becomes 1, you leave it as it is. So imagine utility of good 2. Differentiate it, our dummy is Q1. So leave it as it is. So in this case, what have we established? Our function will be as follows. So I'll give you an idea, but that will also be a homework because it's going to come in your test 1. So to maximize, we need to to know the quantities of good Q1 and Q2. So utility function. So our function will be P1 times Q1, P2 times Q2. So in this case, our P1 was what? 1/4, and our P2 was 4/4. So to come up with a function, we're going to equate that, get our function will be 120 is equal to 1 Q1 plus 4 Q2. This is our budget line. Then our utility function, since we're given Q1, Q2, so du dQ1, and that means simply Q2 du. So this is our marginal utility of what? Of good 1. Du over the Q2 is the marginal utility of good 2. Further later, which is Q1. Then how to maximize the function? mu1 over price of 1 should be equal to mu2 over price of 2. In this case, mu1 is Q2. The price of good 1 is what? 1/4. mu2 is Q1. The price of this one is 4/4. When you cross multiply, you're going to have Q1 is equal to 4Q2. So now this is what you substitute in the budget line. So where there is Q1, we're going to put 4Q2. So here, we're going to simply have, are we together so far? It's 15 marks. And people perish because of lack of knowledge. So people are repeating this course so much because they're not able to understand much. So where is Q1, we're going to put 4Q2. And here we're going to have 4Q2. So here 120, we'll put 8Q2. So when you divide both sides by 8, that is 8 into 120.
15.
It's how much? 15?
Yes.
Right. So Q2 will be 15. So meaning Q1 will be 4 times 15. What do we get? 60. So this is how this question was supposed to be done. I will ask you to take your time to really digest this. Thank you so much for your time.